Hey everyone, welcome. Today, we're going to pull back the curtain on the secret language of predictability. It's called uniform motion. Now, that might sound a little complex, but trust me, it's the super simple, elegant rule that's behind everything from a satellite zipping around the Earth to that delivery drone heading to your house. So, let's dive in and see how it all works.
I mean, have you ever really stopped to think about this? How in the world does your GPS predict your arrival time, like down to the minute? It's not magic, even though it feels like it, right? It's all physics. And it all boils down to this one core principle, one of the most basic types of movement there is. And that is exactly what we are going to unpack today. Okay, so to really get this, let's start by picturing a world, or maybe just a type of motion, that is absolutely 100% predictable. A world where you know exactly where something is going to be with no mystery at all. And that is the key right there. We are not talking about something chaotic, like a butterfly flitting around or a leaf tumbling in the wind. No way. We are talking about motion that is so consistent, so incredibly steady, that if you know where something is right now and how it's moving, you can predict its entire future path. So, what are these rules? Let's find out. All right, the official physics term for this super predictable movement is uniform motion. And really, that's just a fancy way of saying an object has a constant velocity. So, what on earth does that mean?
Okay, lean in for this part because the word and here is absolutely crucial. See, velocity isn't just about speed, it's a two-part deal. It's a package that includes both how fast you're going and the direction you're headed. For your velocity to be truly constant, neither of those things can change, not one bit.
So let's break it down into two dead simple rules. Rule number one, constant speed. That means no speeding up, no slowing down. Your foot is steady on the gas. Rule number two, constant direction. That means no turning left, no turning right. You're traveling in a perfectly straight line. You nail both of those, boom, you've got yourself uniform motion. And here's the really cool part. Because this type of motion is so simple and predictable, we can describe it with a formula that is just as simple, but also incredibly powerful. This is basically our prediction toolkit. Okay, here's the foundation of it all. Velocity equals distance divided by time. That's it. So if you drive, say, 100 kilometers and it takes you exactly 1 hour, your velocity is 100 kilometers per hour. Super simple, right? Now, this is where it gets fun. We can just shuffle that formula around a little bit to start making some real predictions. If you know your constant velocity and you know how long you're going to be traveling, you can figure out the exact distance you'll cover. And yep, this is the very formula your GPS is using to tell you how many miles you have left. And if we rearrange it one last time, we get our final tool. If you know the distance you need to go and you know your constant velocity, you can calculate exactly how long it's going to take. And there it is. That's precisely how your GPS figures out your ETA. So now that we've got our complete toolkit, let's, actually use it to solve some stuff. All right, Siri is great and all, but let's put these formulas to the test. Let's do a couple of quick examples, because this is where it's really going to click. Okay, first problem. We've got a cyclist. They're moving at a constant velocity of 5 meters per second, and they do this for 10 seconds. The question is, how far do they go? So, which tool do we pull out of our toolkit? Yeah, the distance formula. And it's just simple multiplication, right? Distance equals velocity times time. So 5 meters per second times 10 seconds gives us 50 meters. Done. Easy as that. Okay, let's try another one. This time, we're going to solve for time. So imagine a car traveling 120 kilometers. It's holding a perfectly steady velocity of 60 kilometers per hour. So the big question is, how long does that trip take? Well, we just grab our time formula, which is distance divided by velocity. So we take 120 kilometers divided by 60 kilometers per hour, and what do we get? Exactly 2 hours. See what I mean? When you've got the rules, it's all perfectly predictable. So now that we know how to calculate this stuff, let's get good at spotting it in the wild. How can you tell the difference between uniform motion and, well, everything else out in the real world? Here's a fantastic comparison for you. Think about an escalator. It's moving steadily upward, right? The speed is constant, and the direction, straight up at an angle, is also constant. That is a perfect example of uniform motion. But now think about a car pulling up to a red light. That's non-uniform motion. Why? Because its speed is changing. It's slowing down to a stop. And that brings us to a final little brain teaser. I want you to really think about this one.
We know constant velocity needs both constant speed and constant direction. So my question for you is it possible to have one without the other? Could an object have a constant speed but not have a constant velocity? Picture a race car going around a perfectly circular track at a steady 100 miles per hour. What do you think? I'll let you chew on that one. Thanks for tuning in.